section is about calculating functions that are defined implicitly. All that means is that these are functions, they're not always functions, they're curves that they don't look like y equals. They have a mix of x's and y's. If you remember, the equation for a circle is x squared plus y squared equals, let's say, 25. That equation for a circle is an implicit curve, and it's not a function because, you know, circles go all the way around, so it fails a vertical line test. So we're going to look at today how you would take a derivative of something that looks like that. So here's an example. The curve is defined implicitly. It doesn't look like y equals at the end. It's got x's and y's in the definition mixed together. And it is not a function. It fails the vertical line test a couple of different places, like right here. It fails the vertical line test. However, it still has tangent lines to it. So we can still draw a tangent line to the curve. So we should still be able to figure out what the slope of a tangent line to the curve is. Notice that it has two different tangent lines at x equals -3. So in order to figure out the slope of a tangent line, we're not just going to need x. We will need both the x and the y coordinate to figure out the slope of the tangent line. So here's an example. The first thing we want to do is take the derivative of both sides. But I'm going to use Leibniz notation. We are finding dy dx. We're going to take a derivative with respect to x. When we take the derivative with respect to x of x, we get 1. When we take the derivative with respect to x of y, we don't get an answer, we just get dy dx. Okay? Notice how dx is 1, but dy dx doesn't reduce. So what we're going to do is we're going to take the derivative. So the derivative of x cubed would be 3x squared. Now, we're going to treat y like a function. So instead of this just being 3y squared, it's going to be 3y squared times the derivative of the baby. Because y is a function, so we're doing the chain rule here. And we don't know what the derivative of y is, so we're just going to write dy dx. Or we're taking a derivative of y with respect to x, so it's dy dx. On the other side of the equation, we have a product of two functions. We have 6y, and we have y, which we're treating like a function, so we're going to do the product rule. The derivative of 6x would be 6 times y left alone, plus 6x left alone, times the derivative of y. So as we took the derivative of both sides of that equation, every time we saw a y, we treated it like a function. And we did product rule or chain rule because y is a function as we're doing our derivative. Okay? Now that we've done that, we are going to move all of the y prime or all of the dy dx's to one side of the equation and everything else over to the other side. So I'm going to subtract 6x dy dx from, I'm making the decision to move all my dy dx's over this way. But you could make a different decision. It wouldn't be wrong. I'm also going to move the 3x squared. So this would be -3y squared times dy dx. If you want to write y prime, you may. I get, in these problems, for some reason, I always write dy dx. It's sort of a habit for me. It's also y prime looks like y to the first problems, y to the first power, so that's the other reason I do it. Okay. Now we are going to solve for that dy dx, which means first we're going to factor it out on the left side. and then divide to get dy dx by itself. I want to point out that I made the decision way up here to move my dy dx terms over to the left side of the equal sign. If you had made the decision to move all of your dy dx's over to the right side of the equal sign, then you would have the same answer as I would, but it wouldn't look the same. If you had made the decision to move dy dx to the right instead of to the left, your answer would look like 3x squared minus 6y over 3y squared plus 6x, because all of your signs would be different. Our answers are exactly identical. It's just that if you move to one side and I move to the other, if I multiply by this name for one, you can see that my answer is the same as yours. So that's kind of a word of warning. You might see an answer that doesn't look like your answer initially until you change all of the signs. Okay. So this is an expression for the derivative of this function. It's how you would find the tangent line, not function, because it's not a function, but curve. It's how you would find the slope of the tangent line to the curve. But in order to find the slope, you need both an x-coordinate and a y-coordinate. Because remember, there are places on the curve where 2 points have the same x-coordinate, and so x is not enough to tell me the location on the curve. All right, so here's an example. We want to find the tangent to the ellipse at this ordered pair. Okay, so it's defined implicitly, so I'm going to take a derivative of both sides. X we're treating just like we always do, but y we're going to treat like a function. So the derivative of x is 1 times y left alone plus x left alone times dy dx. Notice how I put my negative sign in front, so I remember to distribute that negative to both terms in my product rule. And then I'm going to take the derivative of y squared, which is going to be the chain rule, so it'll be 2 times y to the 1 power times the derivative of y. And then don't forget, we're also taking the derivative of 7, which is 0. Now, I have a strong preference for numbers rather than variables. So at this point, I'm going to plug in my numbers so that I can do arithmetic instead of algebra. I have negative 2 minus 2 negative 1. I'm also kind of tired of writing dy dx, so instead of dy dx, I'm going to write m for slope because it's a little bit easier to write. And you see how now it's basically an algebra 1 problem. I'm just solving for m. 2. So the slope of my tangent line is going to be 4/5. The ordered pair would be negative 1, 2. So I can write the tangent line equation to be y equals 4/5 times x plus 1 plus 2. The equation for the tangent. This question is asking me to find where the tangent line is horizontal. The way of thinking about that is this is asking me where is the slope equal to 0. So we're going to do implicit. Here's a product rule. So 2x times y left alone plus x squared times dy dx. And here's another product rule. So 1 times y squared plus x. Oh, and a chain rule. 2y times dy dx equals 0. I'm going to solve for dy dx, or maybe I can call it m at this point if that's easier. So I have x squared times m, 2xy times m, and I'm going to move y squared to the other side and my 2xy to the other side. You could have made a different choice. If you did, all of your signs will be different from mine. So now we have a fraction. We want to know when the fraction is equal to 0. So we're trying to figure out when is m equal to 0. So negative y squared minus 2xy over x squared plus 2xy is equal to 0. So we're going to factor that and find the zeros that way. So I'm going to take out a negative y. And again, it's a fraction, so with a fraction equal to 0, we really just want the numerator to equal 0. So just, 0 over 5 is equal to 0. 0 over 10 is equal to 0. I don't care what's in the denominator. I only care what's in the numerator. So one place would be y is equal to 0. And another place would be y plus 2x is equal to 0. So 2x is equal to negative y, or y is equal to negative 2x. Now, we're trying to figure out where this is happening, which means we want to go to the definition of our curve so we can answer a question about where is this happening. So the first thing we want to look at is if y is equal to 0. And very quickly I can see that y equals 0 doesn't exist on this curve. I would get 0 plus 0 equals 6. So it was a good thought, but y equals 0 is not a good answer to this question. There is no horizontal tangent line at y equals 0 because there is no y equals 0. So now I'm going to go and replace y with negative 2x. So x squared times negative 2x plus x times negative 2x squared is equal to 6. That'd be negative 2x cubed minus 4x cubed. So it looks like x is negative 1. It's going to be a solution. If x is negative 1, I should figure out what y is. So I'm going to go back and figure out what y is. Well, y is equal to negative 2x, so y will be 2. So at this ordered pair, negative 1 comma 2, that's where the tangent line has a slope of 0. That was fun. I'm going to stop the video here. I do have some more examples, so I'm going to make a second video. But this is implicit differentiation.